Term 2 statistics students. We are now entering into a new major topic. There are 5 major topics in Statistics 1, and this is discrete random variables. Sounds really tricky perhaps, but it's actually not too bad. I say that about everything, right? Okay, so what is a random variable? Well, a random variable is a quantity that can take any value determined by the outcome of a random event. So let's just imagine you're tossing 2 coins. I think this is the example they give in the textbook. You're tossing 2 coins and a random variable might be x, where x is the sum of the 2 dice. Or it might be y, where y is the positive difference between the 2 dice. So that's a random variable. A discrete random variable is a random variable that takes distinct values, and the probabilities of all of the possible distinct values must add up to 1. They can't be negative or not or add up to more than 1. So that's kind of the definition. So we'll just work our way through a few examples. I suggest you read the examples in the book, but I'm going to do a few examples from the exercise. So the first one is number 1 here. We have to find which of the following are not discrete random variables, giving a reason for any which are not. Well, I'm only going to do one. I'm just going to do the first one. So let's have a look at it here. We have our random variable in this case would be big X, and it can take these 5 discrete values. Okay, it could take a value of little x, 1, 2, 3, 4, 5. So big X can take these 5 different values. And this next line here reads like the probability of x being one of these distinct values is. So we've got probability that it's 1 is 0.2, probability it's 2 is 0.3, that it's 3 is 0.4, etc., etc. Now, I want you to notice something. Let's sum these. 0.2 plus 0.3 is 0.5, plus 0.4 is 0.9, plus 0.3 is 1.2, plus 0.2 is 1.4. Now, we can say, therefore, x is not a discrete random variable, and the reason for that, discrete random variable, and the reason for that is because the probabilities do not add to 1. So for it to be a discrete random variable, the probabilities of these discrete options must add to 1. So far so easy, right? Okay, the next one, number 2. I've got this fair dice that I've thrown, and I have to list the probability distribution for the following random variable. Z is the square of the score on a dice. So I'm rolling this dice, Z is the square of the score on the dice. So I would set up little z here, and what are my options? Well, if I roll a 1, I get square of that would be 1. If I roll a 2, the square of that would be 4. If I roll a 3, the square of that would be 9. If I roll a 4, the square would be 16. If I roll a 5, the square would be 25. And if I roll a 6, the square would be 36. So those are my different options. And my second line is going to be the probability that random variable z is equal to one of these distinct values here of z. Now, each of those are equally likely, so it's simply going to be 1/6. So I could just go along here and write 1/6 for all of those options. It's not rocket science, is it? Okay, number 3. Two coins are tossed. If x is equal to the number of heads seen, list the probability distribution for x. Well, think about this. If you're tossing 2 coins, the fewest number of heads you can get is 0, right? You might get 2 tails. The most number of heads you can get is 2. So you've only got 3 options for this. You could have, little x could be either 0 heads, it could be 1 head, or it could be 2 heads. And our second line of our probability distribution table is going to be the probability that our random variable is equal to one of these possible options. Well, what is the chance of getting 0 heads? Well, we have to get tails and a tails. And the probability of that, if you think back to your tree diagram, is a half times a half. 1/4. Let's go to the probability of getting 2 heads. Well, you have to get a half times a half again, right? So that's going to be 1/4. And therefore the probability of getting 1 is going to be 2/4 or 1/2. And that would be my probability distribution for x. The final one I'm going to do with you is number 4c. We've got a probability distribution table here. And we've got this random variable x, and it takes on these values of x, 5, 6, 8, 9, and 12. And the first step is we've got to find a. Well, let's add these up. We've got 0.4 plus 0.2, which is 0.6, plus 0.3 is 0.9, plus 0.1 is 1.0. So if this is a discrete random variable, a must be equal to 0 because we're already at a probability of 1. Okay, part 2 is I need to find the probability of x being greater or equal to 9. So I need everything that is this way. Well, that's a 0, so 0 is ignored, and I've got a 0.1 here. So the probability that my random variable, discrete random variable, is going to be 9 or above is therefore 0.1.